You are watching Mrs. Perez Module 3, Topic 1, Lesson 2. For this lesson, it says magnificent magnitude, absolute value. So today's going to be about absolute value. We're on page 455, going through our learning goals first. First learning goal: explain the meaning of the absolute value of a rational number and its distance from zero on a number line. The second learning goal: interpret the meaning of absolute value as the magnitude for a positive or negative quantity in a real world context. For 3, it's evaluate the absolute value of a quantity. For 4, compare and order numbers expressed as absolute value and distinguish absolute value comparisons from statements about order. We do have one key term, it's absolute value. Our lesson today is mostly about absolute value. We're going to go ahead and turn to the next page. Next page is page 456, going the distance. We do have a number line here. 1 says plot a point at -7. So on the number line, we're going to find -7, and we're going to plot that point. Okay. 2 says describe the distance from -7 to 0. Well, if I wanted to describe the distance, I could actually call the spots that I keep going to the left, I can call those units. So if I was counting, I would say 1, 2, 3, 4, 5, 6, 7 units from 0. So that's what I'm going to write here. The distance is 7 units. Okay. Number 3, plot as many other points as possible on the number line that are the same distance from 0 as -7. So if I was going to do -7 from, and it has to be another point that is the same distance from 0, well, I would have to go this way because I can't go any more than 7 to have the same distance on this side. So I'll gotta go 7 units this way. If I did 7 units this way, I would actually end up at +7. These two numbers are the same distance away from 0. 4, how many numbers did you plot? Well, here we could only plot 2 numbers. The reason why is that there are only 2 numbers the same distance from 0, and that would be positive and -7. Okay, going on to the next page. We are now on page 457. We are going to skip this part and move on to our key term. If you happen to have your key term journal, this is the time to go ahead and get that out so you can fill in your blanks. The magnitude or absolute value of a number is its distance from 0 on a number line. The symbol for absolute value is these 2 lines here. Whenever you see these 2 lines around any number, for example, if I had -2, that would actually be equal to 2. If I had the absolute value of +2, I would still have 2 because absolute value is the distance. It's not about the number really, it's about the distance from the number 0 on a number line. Okay. The expression absolute value of n is read as the absolute value of number n. Okay, moving on. We're now on page 458, and you'll notice that there's a number line here. And if you didn't know already, number lines can be up and down, left and right, and we'll learn more about that later on in 6th grade. Number 2, plot 7 on the number line. So we're going to go, plot 5 on the number line. So we're going to find 0. We're going to plot 5 on the number line there. Still labeling, even though I'm plotting here. How far is 5 from 0? Well, 5 is 5 units from 0. B, the absolute value of 5 would be 5. Okay, plot negative 4.2. Goodness. Negative 7.2 on the number line. Negative 7.2. And how far is that from 0? Well, that would be 7.2 units. Notice when we talk about distance, distance is never a negative. It's always a positive. We never have a negative when it comes to distance. So even though it says absolute value of negative 7.2 here, my answer for the distance is still going to be 7.2. Number 4, explain what each statement means. Name any other values that have the same absolute value if possible. So if we were looking at this, A, I have absolute value of negative 5. Well, that would be 5 because absolute value is always positive. B says the absolute value of 1 and 5/6. Well, that would still be 1 and 5/6 for the distance. Going to C, you have absolute value of 0.75. Well, that would still be the distance. D, absolute value of negative 1.36. Again, absolute value is never a negative, so this would be 1.36. Okay. Moving on. We're now on page 459. We're going to look at these situations and absolute value statements and fill in this table. Absolute values are used in real-world applications when you are interested in only the number and not in the sign of the number. When you look at a temperature changes, you could say the temperature fell by, decreased by, or increased by an absolute value. One says complete the table with the appropriate situation, absolute value statement, and or number. For the last row, assign the correct units to the number based on your situation. We're not going to come up with that on this table. We're just going to fill in the blanks. Here, you'll see the situation. The temperature went from 55 degrees Fahrenheit to 5 degrees Fahrenheit. That went down. And you'll notice the absolute value statement says the temperature fell by. Fell by means that it went down. It didn't go up, it went down. So if I was going to write my numeric example of that, it would be negative 50 degrees Fahrenheit. Going on to the situation. The bank account balance went from 2,500 to 2,250. Well, I got to think. Well, if it went down, that means he didn't earn the money. He probably spent the money. So I'm going to go ahead. He spent $250. There's multiple ways I could have wrote this. I could have said that it increased or decreased or fell by. I could have said decreased by $250. And if it's spent or decreased by, that means it would be a negative $250. The bank account balance went from $495 to $615. That meant that he either earned or it increased. So here I could say he earned, because earned also means increased, and it increased by $120. So that's why there's a positive 120 here. I need to find out what I need to put here by reading what they give me. The water level increased by 4.9 feet. So what I could say here, the water level went from 2 feet to 6.9 feet. I could say that. That follows that. Since it increased, that means it would be a positive instead of a negative. Okay. During the hike, the elevation went from 1,125 feet to 1,750 feet. We could use one of these words up here in our statement. The elevation increased, because we're going up, not down. It increased by, and in this case, it would be 625 feet. And since it increased by, it would be a positive 625 feet. Okay. Going on to the next page. At any time, if I'm going too fast, you're welcome to pause the video so you can get your notes. Okay, we're on page 460. You also use absolute value statements to describe how numbers compare with other numbers. You often use these statements without thinking about it. Less than or greater than. Whether you use words like depth, loss, colder, depth, above, hotter, or below. 2, we're going to complete the table with the appropriate situation, absolute value statement, and or example. For the last row, assign the correct units to the numeric example based on your situation. So we're not going to do this part though. We're going to just fill in what we know. A water level less than negative 2.5 miles below sea level. More than 2.5 miles below sea level. So if it's below sea level, that tells me this has to be negative 2.5. And it wants us to have something more than negative 2.5, okay? What they mean here is that they want it where you're actually going down farther instead of above. So the reason why they put negative 3 miles here is because negative 3 would be actually farther left on the number line. Account balance less than negative $30. So they want something less than. Less than means I'm going farther to the left. So I need a number behind the number line, or behind the negative sign, that is going to be more than 30. It's a debt greater than $30. So I could put negative 35 here. A weight less than negative 7.5 of previous weight. They lost more than 7.5 pounds. In this case, I could say negative 8 pounds. Okay, and remember pounds is LBS as the abbreviation. A dive to the height less than negative 350. Since it says less than, I need to have something that's more to the left on the number line instead of to the right. We could say for our statement, deeper than 350 feet below the water. And if I wanted something more to the left than negative 350, we could do 400, negative 400, okay? Colder than 10 degrees below, okay? Colder than 10 degrees below. Since it's colder than 10 degrees below, then I'm going to do negative 15 degrees Fahrenheit. And again, this can be any number that is more to the left on the number line than negative 10, okay? A temperature, we could say this could be a temperature less than negative 10 degrees Fahrenheit, okay? A depth greater than 15 meters. A depth, so that means it's negative and it's greater than the negative. So that's going to be it could go just 16 meters. Okay. This could be a level less than negative 15 meters. Because it has to be less than negative, which this would be that. It's more to the left. Okay, going on. We're on page 461. Here, number 1 says, in many buildings, particularly outside of the United States, the ground floor of a building is labeled as G, or lobby. The first floor of the building is 1 floor above the ground. The building pictured as a lobby, 10 floors of offices and 4 floors of garage below the lobby. So we could look at this building as a number line. We could say ground would be 0, and then this, when you're going up, would go above. So those would be your positives. And then going below would be your negatives. Okay, so we could think of it like that. We're going to use that knowledge to answer the next questions on page 462. Write a numeric expression using absolute values that would represent each situation. Then calculate the answer. Okay, so B. Caleb parks his car on the 2nd floor, and it's 2nd floor below ground. Okay, so it's below the ground, and we said on this building below ground would be negatives. Okay, but we're talking about absolute values, so it's going to be absolute value of negative 2. And we're going to add that to our next one. Okay, and works on the 7th floor. So since he works on the 7th floor, he would have to go from the ground to the 7th floor, would be the absolute of 7, because he's going from ground up. How many floors must he go up from his car to reach his office? Okay. So here, we would actually add that together. But remember, absolute value is always positive. So this absolute value of negative 2 would actually be 2 plus the absolute value of 7, which here we found out that it would actually be a total of 9 floors. Okay? Going to C. Lucinda is working on the 8th floor, so absolute value, positive 8. At lunch, she goes to her car on the 4th floor below ground, okay? So she goes to the 4th floor below ground, so that's absolute value of negative 4. And then back up to the lobby. Okay, so when she goes from below ground and back up to the ground level, she's actually going positive 4 up. Okay, now we have to put how many total floors. So absolute value of 8 is 8. Absolute value of negative 4 is 4. The absolute value of 4 is 4. And when you add that all together, you would get a total of 16 floors. Okay, D. If Damon goes from his office on the 10th floor, so he's on the 10th floor, to a meeting on the 5th floor, so from the 10th floor down, so he's going down, so that would be negative instead of positive. He's going down to the 5th floor. How many floors does he travel in which direction? Okay, so absolute value of 10 minus the absolute value of 5, he would go down 5 floors. Okay. Okay, we're going and skipping to page 464. You absolutely must compare these. Insert a greater than, less than, or equal symbol to make each statement true. justify each answer in terms of the definition of absolute value in number lines. Okay, so here, number 1, you got the absolute value of negative 4.67, but remember, absolute value is always going to be a positive. Absolute value of 3. Okay, now looking at these, which one's greater? Well, 4 is more to the right on the number line, so that one would have to be greater. Okay, number 2, the absolute value of negative 15, well, that would be positive 15 since the absolute value. And then absolute value of 15 would be 15. Well, those are the same numbers. Even though it's absolute value with the negative here, they're both with the distance of 15. Okay, 3. This is absolute value of 25 and 9/10. And then even though there's a negative, that's going to be 33 and 2/3. I don't even have to look at the fractions. I can look at the number in front of the fractions. 25 is less than 33, so that would make my inequality less than. Absolute value is 13.45. And again, negatives are not a thing with absolute value. Yes, it's in the symbol here, but it's still going to be a positive because that's distance. Now, let me see. I can just look at the number in front of the decimal to compare. 13 is less than 27, so that would be my inequality. Absolute value is always positive. Again, absolute value is always positive. I just have to look at these numbers here, the 1 and the 15. Well, 15 is definitely greater than 1, so that would be greater than. Okay, last one. Okay, I just have to look at the numbers, 5 and 19 here, and 19 would be greater than. Thank you for watching, and watch as many times as you need to get all your notes. Thank you and have a great day.